In this video, I will demonstrate how we can use the Binwalk tool for firmware analysis and reversing. This is a common method used in IoT hacking for when we do not have access to the physical device. So as you can see from the GitHub page for the Binwalk tool, well, Binwalk is a fast, easy to use tool for analyzing, reverse engineering and extracting firmware images. Okay, run the following command to install the Binwalk tool and the relevant dependencies. Okay, so as you can see over here, we have the firmware file for the E1200 version 2.0.2 for the Linksys router. So .bin is basically just the firmware file extension. Also, I've provided links to firmware files for your own experimentation. So as you can see, if you run the Binwalk command on it, run the Binwalk command on it, you can see that we have a few output over here. And it tells us that there exists a squash.fs file system. So now let's run again, but with the .e flag or extract, basically to extract the file system. As you can see, no errors. And your output, the following extracted file. So let's give it a list. You can see the squash.fs root. Alright, now let's view this particular file. But you can see that it is an empty directory. This happens because the firmware utilizes a vendor modified squash.fs format, which cannot be passed by the native utility found on a standard Linux installation. But to fix that, we can use the Sasquatch tool instead. Okay, so to install it, first I have to install a bunch of dependencies. So as you run it, you can see, key in the password, yes, then it will install blah blah blah. Okay, so it's pretty fast for me because I've already installed it. So next, after this, we can clone the repository from GitHub. So yes, okay, clone into the Sasquatch folder. You can see over here, cd into it. Okay, you can see the build sh script. Okay, clear screen. Next, run the build sh file with a bunch of options over here. These basically are just compiler options. So I found this to work for me to suppress certain errors that I encounter when I run this script on my Ubuntu machine. So I'll skip this step because I've already ran this. But right after you run it, you can see that the Sasquatch binary will be available at a certain local directory. Once again, you can access my notes where I provide the installation steps in the description below. Run once again the Binwalk extract command on this binary file. Firmware file, sorry. Alright, okay, we see a bunch of warning messages, which does not matter. It just basically refers to the symbolic link, security stuff. But anyway, so we can see extracted file system, list it. And once again, go into the squash.fs root. And you can see over here, the familiar Linux file system. Okay, let's take a look a little bit further into it. Okay, www. Alright, you can see a bunch of files with HTML extension, blah 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 JS on the actual device provided by the firmware. So with access to the file system, we can investigate further to find potential 0 days or hidden bugs. So we can look even further besides the www directory. For example, usr sbin, where we can potentially find custom binaries which may be potentially vulnerable to command injection vulnerabilities or even stack-based buffer overflows for us to investigate and potentially craft an exploit for. Talking about command injection, check out the video over here to learn how I exploited a D-Link router using firmware emulation, or the other video to learn how I hacked a physical copy of the Linksys router used in this video. Thank you so much for watching. I hope you have learned something from this video. Like, subscribe and comment down below if you would like a part 2 on the Binwalk tool.